my channel MuleSoft Unleash. CSV and flat files look simple until they break your integration. In this video, we'll see how DataWeave handles reading CSV, writing CSV, and finally how to convert data into a flat file format the right way. Let's break it down step by step. Part 1. Reading CSV in DataWeave. Let's start with reading a CSV file. DataWeave reading CSV is all about setting the correct input MIME type and reader properties. Here we define the input as application CSV. By setting header true, we tell DataWeave that the first row contains column names. The separator is a comma, quotes are handled using double quotes, and backslashes are used as escape characters. Once the CSV is read, DataWeave automatically converts it into an array of objects. Each row becomes an object and every column becomes a key value pair. One important thing to remember, CSV values are always read as strings by default. So when we need numbers, like an employee ID, we explicitly cast them using as number. This approach gives us clean, structured JSON that's easy to validate, transform, or send downstream. Part 2. Writing CSV in DWL. Now let's flip the flow and write CSV instead of reading it. Here we set the output MIME type to application star CSV. The header true option ensures column names are written as the first row. We also define the separator, quote, and escape characters to control formatting. The input data is a simple array of objects. Each object becomes a CSV row and the object keys automatically become column headers. One common mistake developers make is using reader-only options while writing CSV. For example, skip empty lines is not valid for CSV output. Instead, writer options like ignore empty line, quote values, or line separator should be used. The result is a clean, predictable CSV file, perfect for reports, exports, or legacy systems. Part 3. FFD. Now let's check flat file definition or FFD and understand how MuleSoft uses it to parse complex COBOL style batch files safely and correctly. An FFD or flat file definition is essentially a schema for fixed width files. It tells Mule how to interpret raw text lines, which record is a header, which is a transaction, and which is a footer, including field lengths, formats, and validation rules. High-level file structure. Let's start with the big picture. This file begins with a request header, followed by one or more batches. Each batch contains a header, multiple transaction records, and a footer. Finally, the file ends with a request footer that validates the entire file. The form matters as it is set to flat file, which means this is a fixed width format. There are no delimiters. Every field has an exact position and length, and Mule enforces that strictly during parsing. The structure section defines the logical hierarchy of the file. It enforces rules like the file must start with a header, each batch must contain at least one transaction, every batch must end with a footer. If any of these rules are violated, Mule throws an error. Each segment represents a physical record in the file. Mule uses tag values like RQH, BAT, and RQF to identify record types and route each line into the correct structure automatically. Batch footers and file footers are not optional. They contain totals and counts that allow Mule to validate data integrity, a pattern straight from mainframe batch processing. Once Mule parses the file using this FFD, you no longer deal with text. You get a fully structured object, headers, batches, transactions, and footers, ready for DataWeave transformations. Understanding FFDs is critical if you work with COBOL, mainframes, or enterprise batch system. Let's check out a clean, real-world DataWeave mapping that shows how this FFD parses into a structured object and how you map it to a usable JSON output. I'll do this in 3 steps, so it's easy to understand and teach. Step 1. What Mule gives you after FFD parsing. After the FFD is applied, the flat file is no longer text. Mule produces a hierarchical object based on your structures section. Conceptually, the payload looks like this. This structure is guaranteed by the FFD. No manual parsing required. Step 2. DataWeave mapping, flat file, API ready JSON. Here's a production ready DataWeave script that maps this payload cleanly. Step 3. Final output, what the API receives. Why this mapping works so well uses FFD generated hierarchy. No string slicing or manual offsets naturally handles multiple batches transactions, clean separation of header, detail and footer API ready and audit friendly. In the next lesson, we'll continue building on this and transform even more complex structures. If you're enjoying the series, make sure you like the video, subscribe, and check the playlist for previous days.